Alright, so on to functions. Now when we say a function is onto, a function can be onto if the range is equal to the codomain. So let's show it. Now okay, we have the domain. So let me have 3 here. Let's see 4 here. Alright, now then codomain, we have M here and O P. So that's this one also this that this one. Let me draw this one well. Okay. Now let's check the codomain. Now this is the domain. This is the codomain. Alright, so the codomain we have N, O, then P. So let's talk about the range. Now in our previous lesson we explained about the range. So the range can be found in the codomain. So we said the range is a subset of the codomain. So M N O P are the range. So M N O then P. Now let's have a quick look at the codomain, then the range. Now we have M here, N here, in there, O here, O here, P here, P here. Now if it happens this way, it means the function is onto function. So we define onto function as if the codomain is equal to the range, we call that function onto function. So onto function, the function which has the codomain equal to the range. So if the codomain is equal to the range, that function is termed as onto functions. So that's that. Now to proceed, don't forget to subscribe to this channel in order not to miss the next video. Alright, so the next thing we are going to look at is inverse of a function. Inverse of a function. So for inverse of a function, in case you have this one, that is the domain. So let me continue. So we have 3 here, then we have 4 here. So we have P here, M here, T here, and U here. So this one found to this. Alright, and then let's name this one X, Y. So this one is F. Okay, so let's move on. Right, now if I interchange X and Y, keep on X and Y, so the Y will be here. Now don't forget under Y have P and T U. So P n t u. Then the x will also be here. So 1, 2, 3, and 4. So like that. Like this one. Okay. So the moment we interchange x and y, this one also change. That is the f change to be the inverse. So we have small minus 1. That is, call this one the inverse. So the moment we change x and y, this one also change to be the inverse. So that's the explanation of the inverse of a function. So this is the domain, and this is the codomain. So this is the domain, this is the codomain, and here we have interchanged x and y, their positions. The moment x and y changes, this one also change. So we have f here, so this one is also here. So that's the inverse of a function. So this one, f to the power minus 1, and that this topic is not the same as 1 over f. So not the same as 1 over it. This is just a denotation. So we call this one inverse of a function. So inverse of a, so to find the inverse of a function, you first of all let y represent the function. Yeah. Now let's continue. Now to find the inverse of a function, first of all let y represent the function. After that you interchange x and y, and the last time you make y the subject. So now let's solve this example. For example 1, find the inverse of the function. Now we have f of x. So solution. So this is the function f of x. F of x seven x minus 5. All right. Now to find the inverse, first of all let y represent the function. So y will be the function f of x. F of x. All right. F of x. So we say y equals 7x minus 5. Okay. So the next thing to do is interchange x and y. So interchange x and y. X and y, their position. So it means where you see y, you make it x, and where you see x, make it y. So this one, I'll make this one x. So we have x here. Then this one to make it y, 7y minus 5. Okay, so the last thing to do is to make y the subject. So we are going to make y the subject. So we let this one stand there. We have 7y. So y attached to this one will stand here, and then we send this one to the other side. So we have 7y. So we have x plus 5 7y. So we have moved this one to the other side. So the last thing is to divide both sides by the coefficient of y, which is 7. So x over 5 over 7, and then 7. And this one will cancel this. So therefore y x minus 5 over 7. Therefore our inverse of f is the answer. So inverse f inverse is x minus 5 over 7. So that's the answer. Okay, now let's move on to the next example. Now let's find the inverse answer of this. So just try this one. So same thing, let y represent the function. Let y be f of x. Okay, so y, now this is the function f of x. Y equals 11x minus 9. So the next thing is to interchange x and y. So we are going to interchange x and y. So we have x and then 11y minus 9. So let's make y the subject. So we have x plus 9, because then this 9 is negative, so it will be positive when it moves to the next side. So we have 11y. Okay, so the last thing to do is to find y, that is divide both sides by coefficient of y. So x plus 9 over 11 give you y. Okay, so for f inverse, x plus 9 by 11. Okay, all right, so let's move on to the next example. All right, so we have this one, same thing. Let y represent the function g of x. So this one, so y okay, 2x minus 5. Okay, Okay, so we are going to interchange x and y. Don't forget to do that. So we are going to interchange x and y. So 3 2y and it's 5. All right, now let's make y the subject here. So this one we can say this one is over 1. Then we can do cross multiplication. So cross multiplication, let me pick different pen. So we can say this one cross multiplication. So 1 times 3 is 3. Then x out 2y minus 5. Okay. So 3. Let's expand this one. So 2xy 2x y minus 5x. Okay, so we after y, so let's maintain this one here and send this one to the other side. So we have 3 plus 5x two xy so we're going to divide both sides by so this one will cancel this, so y three plus 5x and 2x. So that's the g inverse. So g inverse is the answer here. Yeah. Alright, so let's move on to the next example. Alright, so this is our next example. So let y represent the function. So y is x minus 2. Okay, so we are going to interchange x and y. So where you see y, you make it x, and where you see x, you make it y. The moment you do that, you tend to be inverse. So y minus 5 over 3y minus 2. So we can make this side over 1. Alright, for uniformity's sake, so we can do cross multiplication. So we have 6 y minus 5, then x out 3y minus 2. Alright, so let's move on. 6y minus 5. Now let's expand this one. So 3xy minus 2x. Okay, now we after y, so let's group like terms here. So we have y here and y there, so we have 6y minus 3x y 5 minus 2x. Okay, so let's take y out. So y out, have 6 minus 3x minus 2x. Okay, so let's divide both sides by coefficient of y. So we have 5 minus 2x over 6 minus 3x. So this is the G inverse. G inverse is the answer. Okay, 5 minus 2x over 6 minus 3x. All right. Okay, let's move on. So I think this is our last example for the inverse. We are going to find the image of 3 under the, we are going to find G inverse of 3. Yeah, that is the image of 3 under this. Well, so this one is different from what we've done already, so we are going to represent this one by y. So y x plus 5 over 3x minus 2. So we try this one. All right, so interchange x and y. So y plus 5 3y minus 2, so over 1. So we do cross multiplication, y plus 5 so we have 3xy minus 2x. Okay, so let's group like terms. So we have 5 plus 2x. So we have 3xy minus y. Alright, so this one is the same as 5 plus 2x. So let's take y out. Have 3x minus 1 Alright, so y is simple 5 plus 2x. So we can divide both sides by this one. 3x minus 1. 3x minus 1. So this one will cancel this. So we have over 3x minus 1. So that's the G inverse. G inverse, that is 5 plus 2x over 3x minus 1. We are going to find the image of 3 under this. So it means you are going to replace s with 3. So where you see s, you put 3 there. So we have 5 plus 2 times 3 over 3 times 3 minus 1. So in this, so 5 plus 6, that is 326 over 9, 39 minus 1. So we have 11 over 8. That's our answer. Alright, so in our next lesson we are going to talk about the functional notation and then composite functions. So don't forget to subscribe in order not to miss the next videos. Thank you very much.